So your chemistry, there are two parts, part 1 and part 2. Part 1 2 hours, and part 1 2 hours you don't get extra time 10 minutes, but part 2 you get 3 hours and 10 minutes. Even O-level science papers they give the part 2 10 minutes extra, the reading time. You can use that for reading or writing, it doesn't matter, but you get extra 10 minutes. That is actually to select the questions, right? Because each part A and B you have to select 3 questions from each. Part A actually compulsory, all 4 are compulsory, but part B, right? Part B you have part B and C, you can select 2 questions from each part B and part C. Now you can see in this paper, now we are doing general chemistry. So general chemistry you are getting one essay type and one structured essay. The structured essay question number 1 from general chemistry, right? So that's what we are doing now. Our target, this one, that's what we are doing the revision now. And then you can see the essay types. You don't get general chemistry only from the other areas, 3 areas: physical, organic, and physical chemistry, organic, and inorganic. So what are the other 3 main areas? That's under essay type. You get physical. Now we can see all these physical. Question number 5, 6, and physical chemistry, very important, and you get here physical plus inorganic small part, question number 7. And then next part C also you can see organic, inorganic, then industrial and environmental chemistry. So what is the hardest part for most of the students? So they find it difficult, physical chemistry part, right? Physical chemistry part. And so this general chemistry also, this is mainly from what? Unit 1, unit 2, and unit 3. From first 3 units, mostly from unit 1 and 2, right? So that is your first, second, and third chapters. First and 2 more significant. For the question number 1 is structured, it is compulsory. So the other 3 from inorganic, physical, and organic. So you get this part, you get, if you take out of 100 marks, this one you get for 2 questions from here and 2 questions from here, right? So 50 MCQs you get 50 marks, 50 MCQs you get 50 marks, then the remaining 50 for the part 2. Out of 50 marks here, this one you get 7.5 actually out of 100. I'll tell out of 100 this one you get 5 into 4, 20 marks. 5 into 4, 20 marks. I mean out of 100. There are 4 compulsory questions. Then part B you get 7.5 into 2, 15 marks. Then this one you get 7.5 into 2, again 15 marks. So that means part B and C you get essay type, you get 30 marks. 30 marks total, and here you get 20 marks. That's how you get 100. Please raise the hand those who are aware of this. I mean the structure of the paper and marks allocated for each section. If you had done this before, if you have got this from the theory class, then no need to waste much time. Anyway, you should know the structure of the paper, and before you do the paper class, you should know the structure of the paper. That's a bit important. That's why I thought of every day I will give some extra knowledge also. So you should be well prepared for this. You should know what type of paper you are getting, right? So this is A level part 2. You can refer this, the other 3 subjects also is there. So this is the chemistry one. Physics, biology, and combined maths also you have in the same booklet. You can view that, you can refer that to have an idea of the paper you are getting. Okay, so this one out of 100. So this is how you get 100 marks. 100 marks. Right. So this 50 MCQ is very, very important. 1 mark each. Each MCQ 1 mark. 50 MCQs. 50 MCQs part 1. So not for part 2. This is 50 MCQs for part 1. So that is for the paper 1. And paper 1 and 2 both periodic table is given. Calculators are not allowed. Periodic table is given, but calculators are not allowed. Okay, so if you have any questions, you can ask, or you can raise hand, or else you can unmute and ask, or else you can put to the chat if you have any other thing to know about the structure of the paper. And you have a project, group project, plus you have to I mean, some schools they strictly check the 80% attendance before you apply, and the other one, your practical record book, that also you have to record the practicals and get the signature of the subject teacher or the sectional head. Right, then okay. So let's see, I'll erase the screen. Let's see the paper. Now we are discussing about this paper. This paper we have done until question number 35. Question number 35. 35, 34 also we discussed. There's a small correction I think I gave. I told you the 50 MCQs you get, right, this also you should know. Your 50 MCQs you get 1 to 30, like you get 5 choices, right? Multiple choice questions. So MCQs you get first 30 MCQs 1 to 5, like there are 5 answers, and then 30 to 40 you get A, B, C, D type questions like this. So then they give the instruction, if A, B correct, like 1, like that, if B correct 2, if CD correct 3, and if AD correct 4, if any other choice 4, right, 5, like that. That also if you only can copy it on somewhere. The first 30 MCQs you get 1 to 30 MCQ paper 1, 50 MCQs ne? So this is how you get 50 MCQs. The first 30 actually is not that hard, but 31 to 40, that's a, okay, 1 to 30 there are 5 answers, right? 1 to 30. Then 31 to 40, right, you get A, B, C, D, and 41 to 50, you get the statement questions. There are 2 statements, first statement and second statement. That's what we are doing now. So first statement and second statement, right? So here if you take now this ABCD type questions are little harder than 1 to 5. So this one anyway 1 out of the 5 answers. This one, if AB correct, first answer. If BC correct, second answer. If CD correct, third answer. And if AD correct, fourth answer. Any other choices, fifth answer. That's how you get. And the statement questions, this one you are getting, if first one is correct, second one is correct and explain, then first one. If both are correct, does not explain, that means there's no correlation between the first statement and the second statement, then you get the answer second. Then if first statement true, second statement false, answer will be 3. Then first one is false, second one is true, answer is 4. If both are false, incorrect, both the statements incorrect, answer is 5. So this the last 10 MCQs, so it's little difficult than 1 to 40, and 31 to 40 also little difficult, because you have to exactly check whether the statement is correct or wrong. Therefore 50 MCQs, so there are 3 groups, right? There are 3 groups, 1 to 30, 31 to 40, and 41 to 50. Any questions? So are you aware of these things? Then next part, and you have to, if to go for A pass, at least you have to get 40 plus. So now if you can get maximum, that's good, because what matters here are not the marks, the study score, So you have to get 40 plus. Out of 50 MCQs, if you can get 40 plus, that's good. 40 plus. That means at least 45, 46 is really good to go for A pass with good study score. Right. Right. Then next one. The question we were discussing about, question number 30, revision 1. Question number 34 also I gave the answer. Diamond, there's a small correction. This one I think I gave the answer second or first. So I told you both these statements correct. Diamond and graphite. Diamond allotropic form of carbon and does not conduct electricity, correct? Diamond no free electrons. And the other one, diamond has giant structure where each carbon atom is covalently bonded. Covalently bonded to 4 other carbon atoms. That means there are 4 covalent bonds. Covalently bonded to 4 other carbon atoms. So I think I give the answer second. Actually this one the answer should be first one because it explained, right? Because of 4 bonds, 4 covalent bonds around carbon atom, there are no free electrons. In graphite there are 3 bonds. In graphite there are 3 bonds. In diamond there are 4 covalent bonds. So this is number 1 graphite, this is number 2 diamond. So carbon outermost shell 4 electron, 1s2, 2s2, 2p2. 1s2, 2s2, 2p2. So therefore all 4 electrons are used up for the bond formation in diamond. That's why no free electrons left. Therefore there's a correlation between the first statement and the second statement. That's why the answer should be here, the first one, right? Not the second. So that one you have to make a small correction. As I remember, I told answer second last week. It should be the first one, right? Actually, anyway, these are most of them are A-level past MCQs from 1990s. Some selected important MCQs from you should have the past papers at least from 1990 until 2020. At least 30 years papers you have to do before the A-level exam. 20 from 1990 till until 2020. So at least 30 years papers you have to do. So chemistry, don't worry. Anyway, in the revision class, paper class, I'll be discussing at least 30 years past MCQs from each chapter, from each section, from each unit. Right? So please raise the hand those who have got the past paper book at least from, those who have got at least from 2000 onwards, the past papers. If you don't have, don't worry. Anyway, chemistry, if those who have got the past paper books at least from 2000, only one. Okay, right, no problem. Don't be in a hurry like to go to visit the bookshops and buy, because these days you don't go out because of this COVID. But if you know someone who has done A level, then like maybe 1 or 2 years back, then you can ask from them the past books they must be having, or else the chemistry anyway, don't worry, I'll discuss all the questions from 1990 onward. And remember the A level syllabus, the English medium started in 2000, as I remember, 2002, right? 2002 A level English medium started in Sri Lanka. A level English medium. Before 2000, no English medium, only Sinhala medium was there, right? A level English medium subjects, the exam was held from 2002 onwards, but there are some publishers, those who have translated the 1990s also papers into English. Okay, so then question number 35 also, did I tell the answer? 35 alpha particles. So gold plate, gold foil experiment, Geiger and Marsden gold foil experiment, discontinuous nature and discovery of the nucleus. Geiger and Marsden, the two students of Rutherford, did this experiment, and then that helps to discover the nucleus, and they found that most of the space around an atom is empty because of this gold foil experiment. Have you, please raise your hand those who have done this in theory class, gold foil experiment. Those who have learned the gold foil experiment in the theory class, please raise the hand. Otherwise, I don't need to explain. Run Seloni. Okay, all the others done, right? Okay, so gold foil experiment, most of the alpha particles are answered you haven't done, right? Anyway, you can refer, but it should be done. but it's there in the syllabus. Wait, A level. 1 second, I will get the resource book. You have the resource book, right, Ransiluni? If you don't have the resource book, please tell me. I will separately post your WhatsApp, because general chemistry first 3 lessons ne. So, but anyway, remember, A level paper, you get maximum 1 MCQ from these things. Some teachers, they spend long time on these cathode ray experiment and these stuff. But anyway, remember this historical background of chemistry. You don't get much questions. Zishan, didn't I? Okay, answer, no problem. Quantum numbers. Okay, some of them they start. Okay, answer and cover them later. Okay, no problem. Who has not got? Zishan, you have not got, no? Okay, please send a request. Otherwise, I will post your WhatsApp separately. That this resource book, or else you can go to the ni.lk website and get it. If not, tell me. I'll post. So this historical background. Remember, you are not getting much questions. You will not get. Basically, they haven't asked this in essays or structures. They haven't asked this atomic structure. This part they haven't asked. Therefore, my advice, don't memorize all this stuff in detail. This atomic theory, that part, the most important part, if you want, you can put a star here. This quantum numbers, very important. You have to pay more, because that's introduced to new syllabus in 2011. Quantum numbers introduced, because before 2011, no questions from quantum numbers. Here, these orbitals and quantum numbers, it's important. Every year you get a question from this. And electronic configuration, anyway, they don't ask separately what is Hund's rule and all, what is Aufbau principle, they don't ask. So configuration you need to remember, but that also very rarely they ask to write the configuration of this element and that element. They haven't asked, very rarely. And out of this, this is bit important, ionization energy graph and this electromagnetic spectrum. Right? This part is bit important. This one you should know bit in detail, so you have to put more weight. Number 1, quantum numbers, very important, quantum numbers. This part actually historical background. This one you can get the first MCQ in the LL paper. That's it. Is history, right? History of chemistry. So that one you don't get big questions. Never in the essay or structure essay. Mostly MCQ first or second. Right? Therefore, my advice, don't memorize that history. And this part bit important, hydrogen spectrum, very important. After that, this hydrogen spectrum little important. Long form of the periodic table, anyway, that's only from the periodic table. Also you can get 1 or 2 MCQ, maximum 1 MCQ. That's it. Like, therefore the unit 1 atomic structure, the most important part is what? Quantum numbers. Maybe that's why your teacher has started this with quantum numbers. That is the most important part. And then the rest. Okay, so therefore you don't need to put the same weight for all the parts, right? So this is a resource book. This is like, because you don't have a textbook, you don't have a textbook. Therefore, this is the only one you have, the reference you have. This is the only reference you have. And remember, this is the gold foil experiment. Ransulini, you can just read it, because you can understand this very easily. This gold foil experiment. So this was done by 2 students of Rutherford. One is Geiger, and we call it Geiger and Marsden. It's a Nobel Prize winning one, Rutherford. Actually, he was he was not a chemist, right? That's the most interesting thing. It has contributed to the chemistry, but he was specialized in physics. Rutherford, you have to learn about this. You have heard about Rutherford, Ernest Rutherford, from all level chemistry itself, right? But he was specialized in physics, but it contributed to the chemistry, and he won the Nobel Prize also. This is the gold foil experiment. So most of the alpha particles, you can see what nucleus, the alpha particles which target, when the target is nucleus only, it's deflected. It's reflected again, return. Most of them are having what undeflected. Most of them undeflected. You can see all these undeflected. I'll highlight them. These ones are undeflected. These This is undeflected. Here the straight lines, here undeflected. This one's on. So this green color, I will increase the size if you want. So all the straight ones, this one, because most of the space around an atom is empty, right? And the nucleus is confined to a small area at the center of the atom. So that's why this red one is deflected. This is called deflection. Deflection, and then reflection, and then the other one is undeviate. Most of the particles undeflected. So deflected ones very few. The other ones scattered. It's like diffraction in other words, right? So the path changes. The blue one. All the other black ones undeflected. So this is an evidence that matter is not continuous. You think it's continuous, so either solid or liquid or gas, all three physical state, discontinuous nature of matter. This is one evidence. That means size of the alpha particle smaller than the space between the atoms, between the nucleus internuclear distance. Okay, so just read it. It's not hard, right? But anyway, you will never get I had never seen in the A-level paper briefly explain the Rutherford gold-foil experiment. You will not get such questions like in history or the other subjects. No point of memorizing this paragraph and to repeat is as it is. You don't need to do it just because just recalling the previous memory. They don't test much in the A-level chemistry paper, even the other subjects, right? But anyway, for the MCQs, you can just read it, right? Okay, so what is the question now? Please, those who are done, you can post the answer to the chat. Those who are done it. 35. Yes, when beam of alpha particle falls on thin gold plate, most of the alpha particles undeflected. That's what I explained just now, no? Most underlined, most of the alpha particles, most, few, always, right? Undeflected. Yes, that's true, right? That is correct. True. The next one, gold plate is non-continuous. So sometimes we call it, if you want to write within by discontinuous. Yes, it is discontinuous. Therefore, there's a correlation between these two. Because of the discontinuous nature or non-continuous nature, most of them pass through, right? So then what is the answer then? Answer is, some of you, okay, Dulshan give third answer. I think true and false. It's true, both are true. And then the next problem is whether it's explained or not. Whether it explains or not. If both are true, the next problem is what? Whether the second statement will be the explanation for the first one. So this one, actually the answer is first one. Answer is first. So there's a correlation between the first statement and the second statement. First statement will be the answer, the reason for the second statement, in other words. Right? Both are correct and explained. Then question number 36. Yes, can you quickly post the answer in the chat, or at least unmute and tell? 36, what is that? Boiling point of graphite is very high. Boiling point of graphite is very high. Is that correct? Yes. Graphite has high boiling point and high melting point. Even diamond, both graphite and diamond has high melting and boiling point, but graphite and diamond boiling point and melting point is slightly higher than graphite, but both, in general, both has high melting and boiling point. Yeah, Dulshan asking the question, what is continuous? So continuous means, Dulshan, there are no gaps here. It's continuous. So if you draw a line, it's continuous line, continuously. But if you draw a line like this, it's non-continuous. That is the meaning of continuous and non-continuous. Is that clear, Dulshan? If you draw a straight line like without leaving any gap, that is continuous. So this is, but that is in the macro scale. That is when you observe through your, I will give one of the best example for this. You take one of the best example. You take a chalk, right? Chalk, like, you know what it is called, made of hunukuru, like we use the blackboard. Okay, so you can put some condis here into this watch glass or something. You can put some condis purple, right? Then you can dissolve some condis in water, and you can keep this vertical in contact with the condensed solution. What happened? So we think this chalk is continuous because it's a solid, but actually what happened? Condensed particles penetrate along the chalk and it turns purple. That means the solid is not continuous. Solid chalk not continuous, it is discontinuous. I'll give one more example. That is an evidence that solid is discontinuous. Or else you take one more example. If you take your bones, sometimes you think our bones and teeth very hard and strong, but if you take gamma rays or some particles, so the radiations can pass through this. If you take your body layers or something, then you can check the structure, lattice structure, you can examine using X-rays or using alpha particles or using gamma rays, like that. If you take liquid, also discontinuous. One of the best example, if you take liquid, you take water and you put some glucose. What is glucose? C6H12O6. C6H12O6. Now between water molecules, glucose molecules can come in between water molecules because water is not continuous. There are small gap between water molecules, so that glucose molecules come and settle here. So therefore glucose solution, after dissolving glucose in water, you get a homogeneous solution. That means glucose molecules can come in between water molecules in the sample of water. Even if you take 100% pure water, it's not continuous. So there are gaps between water molecules. That's why the glucose molecules can come between. If they are continuous, if water is continuous, then glucose will settle at the top. It will exist as a separate layer. But if you take coconut oil, no, because that is because polarity also matters. But anyway, water also not continuous. Then if you take gas, also not continuous. Why? If you take perfume, if you spray some perfume to your shirt, perfume molecules diffuse through air and the other person can get the smell. That means air is not continuous. Between air particles, between gas molecules around us, there are some gaps so that the perfume molecules can penetrate. That means solid is not continuous, liquid also not continuous, gas also not continuous. I'll tell one more example to prove this. You take a concrete slab. This is one of the best example you can experience in your home if you have a slab. Now this concrete slab about like 4 or 5 inches, right? So it's thick, hard and strong. It's a concrete slab. But after a few years, what happened? You can see there's a patch here. If you have a bathroom above, then the lower one, the floor, you can see there's a patch and the fungus grow and it's wet. The moisture has, water molecules has got penetrated. Water molecule can penetrate. That means this concrete slab also not continuous, even though it's very hard and strong. That is a solid. That's why the people you might have heard about this waterproofing. They waterproof this slab. They apply a layer. That also they don't give a lifetime warranty. That means they put a waterproofing chemical here. That's also chemical industry, waterproofing chemical, to prevent these water molecules getting penetrated. That means solid is not continuous. There are some gaps between the particles in the solid, because all three, solid, liquid, gas, they are made of particles. Between particles there are gaps, because if you take an atom, if you take 100% pure gold, 100% pure gold or silver, now between atoms there are, if you take gold atoms, so the nucleus is there, and then around that there are small space, right, between the energy levels. So energy levels are not packed, so there's a gap between the energy levels, right? So that gap is empty. So therefore if you have the gold atoms, then there's a space between these atoms, so most of the space around an atom is empty. Okay, so that is why even 100% pure gold is not continuous. That is called discontinuous nature of matter. In Sinhala is asantatika svabhaya, not santa. Continuous means santatika, discontinuous means asantatika. In the English Sinhala medium chemistry papers or the resource book, they might use this word padarthe asantatika svabhaya. Okay, so nothing is continuous in this world. Nothing is continuous, right? Either solid or liquid or gas, even 100% pure gold. Is that clear? So what is the meaning of continuous and discontinuous? Who asked that question? Dulushan. Yeah. If you have even a small doubt, tell. I will explain the meaning of any word. Okay. So now, what is this non-continuous? So if you want to correct, what is the other term we use for this? Discontinuous. Discontinuous. Okay. Discontinuous nature of matter. Please don't just wait. You have to maintain a separate CR book for the short notes. So right here, all three solid, liquid, gas, all three are not continuous. So all three are discontinuous. So write the example. There are simple activities or the experiments we can do to show the discontinuous nature of chalk dipped in condensed solution. Discontinuous nature of gas or spreading of perfume in air. Right? The perfume molecules diffuse in air because air is not continuous. Right? Liquid, you can dissolve something in water because of the discontinuous nature of if you want, you can dissolve alcohol in water, right? Because of the water is not continuous, right? Then what is the question number 36 we are talking about? Graphite has high melting point and boiling point. Correct the first statement. Second statement, yes. What is the answer for this one? Graphite contains covalent bonds. Yes, both are covalent lattices. That also correct. But the next problem, whether it explain or not. Yes. Please post the answer that you guess to the chat. Then I can have an idea up to which extent I should explain. 36 Ransiruni gave the second answer. Good answer is second. And Dulshan also gave second answer. Very good. Dinitmi also gave. Alright, very good. Those who have posted the correct answer, good. Right. Then question number 37. 37. Boiling point of H. So I'll erase the screen. This part. Question number 37. Right. Question number 37. Boiling point of HF is higher than that of HCl. Is that correct? Okay. Can you quickly post the answer for the 37th MCQ? 37th MCQ. Boiling point of HF is higher than HCl. First statement, true or false? Yes. I told you hydrogen halide HF, HCl, HBr, HI. These are called hydrogen halides. Out of these, all these are polar. Delta plus, delta minus. All these are polar. Delta plus, delta minus. Because there's a electronegativity difference. Electronegativity difference is not zero. Electronegativity difference is not zero. Hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide. So the strength of now, when HF molecule is polar, there's an attraction between one HF molecule to the other HF molecule. That is called intermolecular bonds or intermolecular forces. But this attraction will be stronger when the polarity is high. That means electronegative difference between HF, so hydrogen 2.1, fluorine 4.0. So the difference will be what? 1.9, right? 1.9. 1.9 difference. So higher the difference, higher the strength of intermolecular force. This intermolecular force is very strong. Strong intermolecular force, intercity between cities, intermolecular between molecules, strong intermolecular force. This strong intermolecular force, when the electronegative difference is very high, we call it hydrogen bonding. So what is this intermolecular force called? Hydrogen bonding. Please raise the hand those who have learned about hydrogen bonding under bonding lessons, chapter 2, second lesson. Otherwise I don't need to explain them in detail. Only Dilushan has done. Those who have done the intermolecular forces or secondary interactions, please raise the hand in chapter 2, unit 2. Only 2 of you. Right. Anyway, don't worry. Actually, the reason is due to hydrogen bonding. But HCl, if you take HCl, the strong intermolecular force is not that strong. Like in HF. So if you take HCl, it's 3 and 2.1. Chlorine 3, hydrogen 2.1, then difference will be 0.9, no? 0.9. Therefore, the difference less. If difference is 0, then it's 100% covalent, 100% polar, 100% pure covalent. If the difference is 0, like hydrogen, then the electronegative difference 0. Now, this is known as dipole. That means there are two poles here. I'll mark here delta plus and here delta minus. Therefore HCl is delta plus, delta minus. So therefore HCl is polar and the other HCl molecule also polar. This interaction is known as dipole-dipole. This also is intermolecular force. What is the name given to this intermolecular force or secondary interactions? This intermolecular force is known as dipole-dipole. Dipole-dipole. So all the others having what? Not only HCl, HBr, HI also. What is the main type of intermolecular force? There are different types of intermolecular forces. In oral chemistry, you learn only everything intermolecular, but intermolecular forces also we can classify into different types. So this is HBr, and this is the other one is HI. All these are polar. So the same type in HBr, HI, all three having what? Dipole-dipole interaction. But that strength of dipole-dipole interaction decreases downwards. So I don't tell the iodine and bromine, no need to remember the electronegativity, but down the group difference decreases. So highest difference HF. If you plot boiling point versus this molecule, atomic number of the molecule. So if you take highest boiling point will be HF and then HCl, and after HCl is slightly increase. So this is HCl, this is HBr and then HI, like that. So slightly the boiling point increases. Highest HF. Why is HF having the highest boiling point? Due to the hydrogen bonding. What is the actually, if you get the true statement, HF has the highest boiling point due to the presence of hydrogen bonding, then both are correct and the answer will be first. But here they have given just liquid HF is polar. Yeah, liquid HF is polar. Others also polar. Not only HCl also polar. Liquid HCl also polar. Liquid HF also polar. Both are correct, but it does not explain. Both are correct, but second statement is not the explanation for the first statement. The second one is not the reason for the first one. So the answer is what? Question number 37, answer is second. So how many of you got the correct answer? 37 second. Shamaya correct. Ran Siluni correct. Dinetmi correct. Very good. And Sushan also put second. Is that for 37? When you post the answer, please put 37 dash. Then the answer. Don't just post the answer because I can't. Then I have to check the previous one also with this for the previous question. So this one, that's why. So no need to put dot bracket. So how do we show the reason that reason is hydrogen bonding because HCl? No. Actually, hydrogen also the strength matters. So from molecule to molecule, the strength of the hydrogen bonding differs. That's why. Right. Remember, hydrogen bonding also a type of dipole-dipole interaction. Hydrogen bonding also come under dipole-dipole interaction. That when the dipole-dipole interaction is highest, we call it hydrogen bonding. So HCl, that strength is less, right? Is that clear, Zijan? Yeah, because HCl, HSO you can, but the strength of H, otherwise the boiling point will be same. If both has H, yeah. So what you are saying is correct, but then the HF boiling point should be equal to HCl. So what matters, the strength in HF, the strength is more than HCl. The strength of intermolecular force of the hydrogen bonding strength of HF is greater than HCl. That's the reason, right? Okay. Then if you take water and if you take now, as you said, then water also has hydrogen bonding, but water boiling point is greater than HF. Why? There what matters, water can form more hydrogen bonds than HF. Water can form more hydrogen bonds than HF. Not the radius. Not only the radius here. Right. Because if you take now oxygen sulfur, fluorine, chlorine. So the down the group the radius increases, but you don't need to go to up to that extent for to give the reason. So electronegativity value depends on that or those factors, right? Then next one. Anyway, the answer is second here. Right? Answer will not be the first one. There are some past papers, they have given that question, then they have accepted the reason as the hydrogen bonding in HF. That's why. Even remember H2O has the highest boiling point in group 6. Then H2S group 6, lower boiling point the others. That is actually the when you compare H2S, oxygen, sulfur, selenium, H2SC, H2T, right? So when you compare these group 6 also, the H2O has the highest boiling point because of hydrogen bonding, highest boiling point. Group 7 also, HF has the highest boiling point with compared to the other hydrogen halides because of the hydrogen bonding. The same scenario for the group 5 also. Group 5 ammonia has the highest boiling point because of hydrogen bonding with compared to the others in the same group. We don't need to mention about the atomic radius or the atomic volume or ionic radius or covalent radius or ionic radius, so we don't need to point out those things when you compare. Right. Then question number 38. Question number 38. Chemical and physical properties of isotopes are similar. Okay, can you quickly pause the answer for the 38th MCQ now? Okay, Chamaya and Dulshan gave the answer. What about the others? 38, hurry up. So the first statement, chemical and physical properties. So isotopes, please write everyone, chemical properties depends on the electronic configuration. Please write everyone, chemical properties depends on the electronic configuration. So isotopes of the same element has same electronic configuration. Therefore, chemical properties same, but physical properties will not be same. Therefore, the first statement is wrong. First statement wrong. First statement wrong. Second statement, isotopes have the same number of protons but different number of neutrons. That's correct. That is even oral chemistry also you are learning. Second statement correct. First statement is wrong. Right. Okay, so what is the answer then? Answer is 3. Answer is 4. False and true. Answer is 4. So, Ransuluni correct, Dinetni correct, and Chama also correct. Okay, I'll tell one example. If you take, okay, Ransil and Dulshan, so physical properties. Right. What are physical properties? First, physical properties means density, melting point, boiling point. These are the physical properties. Physical properties means physical properties, so anything like matter. Physical properties examples you can write: melting point, boiling point, melting point, density, texture, malleability, like all this density. So if you take, I'll take hydrogen 1 1, hydrogen 1 2, or we call it deuterium, hydrogen 1 3. So this is deuterium, this is tritium. Right. Now if you take, this one is heavier. If you take water from, we call it D2O, this is H2O protium, and this is T2O. If you prepare water D2O, so deuterium, the second isotope, that's boiling point is greater than, the second isotope boiling point is what? Greater than the first one, first isotope. That's physical properties are different. It's heavier. Heavier. If you make hydrogen gas from the first isotope, it's lighter. If you make the hydrogen gas from second isotope, it's heavier. This one is heavier than H2. That means physical properties are different. Chemical properties, both is having the same electronic configuration. One configuration is one is one. Configuration all the same. Therefore, please write everyone. Chemical properties depends on the electronic configuration. Isotopes having the same electronic configuration. Therefore, isotopes of the same element, having the same configuration. Therefore, chemical properties same, but physical properties are different. Chemical properties depends on the configuration. Isotopes of the same element have same electronic configuration. Therefore, chemical properties are equal. But physical properties, what matters, it depends on the relative atomic mass, mass number, everything, right? I mean, physical properties changes because of this. Some atoms are heavier than the others. So obviously, it's common sense, right? Is that clear now? Who asked that question? Ran, Siluni and Dulshan, right? How physical properties are different. So if you take water, so if you take H2O, it's 18 relative molecular mass. If you take D2O, so it's 2 times 2, 4 plus 16 then 20. So therefore D2O, the boiling point is greater than H2O, right? Because the relative molecular mass differs. That's the meaning of physical properties. If you boil D2O, the boiling point is not 100. Understood? D2O, the boiling point will be greater than 100. H2O boils at 100 degrees Celsius at 1 atm pressure. Okay. Then next part. Question number 39. 39. What is the answer? 39. Can you quickly post the answer to the chat? Those who had done this. Right. 38. Sorry, 39. 39. Right. Let's see the answers. 39. Some of you get the first answer, some of you get the second answer. Right. Solubility of non-polar substances in polar solvent is 0. Is that correct? The first statement. Okay. First statement 0. That is wrong. This is A-level pass paper question. A-level pass paper question. The first statement is false. Why it is false? One evidence. I will give one evidence why it is false. If you take O2 is non-polar. O2 is non-polar. But oxygen dissolves in water. Oxygen dissolves. Water is polar. H2O is polar. H2O is polar. But oxygen, solubility of oxygen in water is more greater than 0. Solubility of O2 in water is not 0. Even though O2 is non-polar. That's why the solubility of non-polar substance in polar solvent 0 wrong. Oxygen dissolve. If oxygen not dissolving in water, then how can aquatic organisms survive? Therefore, solubility of oxygen in water is greater than 0. Oxygen in water is greater than 0. There are so many other examples. Then second statement, intermolecular forces between non-polar molecule and polar molecule are weaker compared to dipole-dipole. Okay. Let's see this one. Compared to dipole-dipole interaction. Dipole-dipole interaction is HCl, HBr, HI. So that between polar molecules, dipole-dipole exists between polar molecules. Between polar molecules. Between polar molecules. And intermolecular forces between non-polar, yes, that is bit weaker. Intermolecular force between non-polar means oxygen. Intermolecular force weaker than between HCl. Between HCl. Right. HCl. Now HCl intermolecular force stronger than intermolecular force between O2. O2 called London forces. And this one we call it dipole interaction, or if you want you can take here even HBr, HI, any polar, H2S also dipole. Both are gases, or oxygen also gas, H2S also gas, but H2S intermolecular force bit is stronger. Therefore the second statement is true. Second one is true, the first one is false. Answer is, if it is false and true, the answer is fourth, right? Answer is false and true. How many of you got this answer? Previous one also false, no? False and true. The previous one also we got false and true. Answer is 4. Previous one. Okay, Ransiloni correct, Dinetmi correct. Dulshan and Chamaya, you give second and first answer. So is that clear, Chamaya and Dulshan, why the answer is fourth? Why the first one is false? Right. Okay. Chamaya, right. Chamaya gave the first answer. I don't know why. Non-polar. Okay, so because you have learned in polar chemistry, non-polar, because of the problem is 0. You can't tell is 0, right? You can't tell it's 0. It's dissolved. Non-polar ones can dissolve in polar to a certain extent. You can't tell it's 0. That's why. Be careful the words in the exam. Actually, it's not only just chemistry. It's a game with words, right? It's some you have the chemistry knowledge, but in the exam, what matters here, it's a game with set of words. So whether it's you have to pay more attention to the words given in the question, tricky words given in the question, especially statement questions. This is A level past MCQ. This 39th one also, 1990s. Okay, let's move on to the next one. 40th MCQ. 40th MCQ, can you? It's a good question. 40th MCQ. The statement, because this paper I have given all 3 types, 1 to 5 answers, ABCD type questions, and general chemistry, the statement questions. So I wanted you to experience all 3 types. Right. Now what is the answer for the 40th MCQ? PCl5 NCl5. Yes, nitrogen and phosphorus, when you write the configuration, then you can easily get the idea. Nitrogen 1s2, 2s2, 2p3. Phosphorus 1s2, right. Phosphorus 1s2, 2s2, 2p6, 3s2, 3p3, 3d empty, 3d 0. So 3d is not, 3d is vacant now. So due to the availability of 3d, so this one can expand. It can go up to now this is very, very important. Second period elements cannot have expanded octet. If you want to write this is the second period, this is the third period, group 5. So please put a stand right, everyone. Second period elements cannot have expanded octet. Elements cannot have expanded octet. One of the best example. If you take now, that's why you cannot have NH5 or NCl5, not possible, because nitrogen second period, nitrogen cannot have 5 bonds around nitrogen. There can't be 5 bonds. Maximum how many? Maximum 4 bonds. Can have maximum 8 electrons. Second energy level can have maximum how many electrons? Second one 8, maximum up to 8. It's become 2p6, 2s2, 2p, then it's become 8 electrons, 2p6. So 2p3 can become 2p6. So therefore maximum 8 electrons. Second period maximum 8 electrons, because nitrogen can have maximum 8 electrons in the valence shell. Maximum 8 electrons, because they can have maximum 8 in the valence shell. Because they can have maximum 8 electrons in the valence shell. 8 are electrons in valence shell. But when it's come to phosphorus, therefore NCl3 can, NCl5 can't. That's the reason. But when it's come to phosphorus, phosphorus can have both PCl3 as well as PCl5. So let's see. Okay, I'll erase this one. If you take phosphorus, so I write quickly the configuration again. Second period phosphorus, so 1s2, 2s2, 2p6, 3s2, 3p3. Now this is vacant orbitals are available. So third one can have a maximum up to 18. This one can have maximum 8 in the valence shell. Maximum 8. Only octet. Only octet. This is very important. Only octet. Maximum 8 means only octet. Octet means 8. Octa. So this one can have up to 18. That means that valence shell can keep maximum more than, that means expanded octet possible. Expanded octet possible. Because 3D also there, but it's 0. Octet possible. Okay. So therefore PCl3 also possible, PCl5 also possible. Right? PCl5 also possible. So it's a good question. PCl5 exists but not NCl5. That is true. That is true. Look at the statements now. Phosphorus atom is larger than nitrogen, obviously, because phosphorus atom larger than nitrogen. Both are correct, right? But is that the explanation? Will that be the explanation? Just because of the larger but that is due to the configuration. So can keep, there are vacant d orbitals. That is the exact reason. There are vacant d orbitals in phosphorus, which can accommodate more than 8 electrons. Therefore it does not explain. Answer is second. Answer is second. Now 40th, actually only Chamaya correct. Only Chamaya gave the correct answer. Dulshan and Ransilani, what about the others? Haven't you learned this in theory class? Expanded octet, incomplete octet and octet. Please raise the hand those who have learned octet, incomplete octet and expanded octet in the theory class. Okay, good, Dinitmi. Please raise the hand those who have learned expanded octet, incomplete and octet and octet. Expanded octet, incomplete octet and octet. What about Chamaya and Chamika? Chamika. Okay. So please add this to your short note. They can raise this question again in the LL paper. Right. So with examples you can write. Okay, I'll give one more example. Here. Shall I erase the screen? Anyone still copying down this? Please raise the hand. If anyone is still copying down this. Okay, I'll erase this. Done, no, everyone. Right, I'll give one more example for this. If you take group 6, oxygen and sulfur, oxygen cannot form OF6. It's not possible. OF6 not possible. Not possible. But SF6 can. SF6 can. Possible. Why? The same reason. Sulfur expanded of sulfur third period, oxygen second period. Please write everyone in a short notebook. Second period elements cannot have expanded octet. OF6 there are 6 bonds, that means 12 electrons. There are 6 bonds means 12 electrons, that's not possible. Oxygen cannot have more than 8. Okay, then I'll erase the screen. That is the 40th one. 40th one, answer is second. Then next one is structure. It said draw the resonance structures of ozone molecule, O3. Now this one actually not the large. Ransulni asking, sir, can we say due to the d orbitals in the atom is large? Actually, not the large. D orbital, yeah, it's large, but that is not the main reason. Whether it's large or small, they should be able to accommodate more electrons. They can accommodate more electrons in the outermost energy level. So that means more than 8 electrons can be accommodated because they have vacant orbitals. Whether it's even the large or small, even though it's large, if it is not vacant, then cannot accommodate. Then structure they say draw the resonance structures of ozone, O3. Please raise the hand those who have done this. Resonance structures of ozone done. I mean, those who have done this answer. Right. So this one I think you cannot post the answer to the chat. If you want, you can separately you can post to my WhatsApp, or else you can any volunteers, if you want, I'll give the permission to share your screen. Some parts, so you can post the answer to the chat. Then the best thing, you can share your screen. You can take a photograph or screenshot and you can share your screen, or else you can annotate on my screen. There are two options because when you are drawing the structure, so it's not possible to post the answer to the chat. Then the best thing, you can share your screen, or else you can post the answer as a file to the chat. As a file you can upload to the chat, or else you can annotate on my screen, or else you can share your screen. There are three opportunities, three options. So this one, if anyone has done it, and if you have the the screenshot or photograph, if you can share your screen, then it's that also I'll give the permission, or else then I can comment on your answer. That's why I'm asking, because you should get the maximum benefit in a small group class like this, right? Anyway, please raise the hand, at least those who have done this. Dushan done. Ransiluni done. Samaya and Chamika didn't me? Okay. This one very important. Your A-level paper structured essay question number 1. Every year you get one from this. Not only ozone, so they can give any other molecule, right? Not very large molecules, some molecules they can give. Not like glucose molecule, not like paracetamol, like simple molecules with few atoms. So what are resonance? Resonance is when there's more than one possibility of drawing, when there's more than one possible structure. When there's more than one possible structure, such structures are called resonance structures. Now if you take ozone, triatomic, homo-triatomic molecule. There are two resonance structures, so we use double-headed arrow. There are two resonance structures for ozone. So each oxygen, now there are three oxygen in the valence shell. There are 18 electrons. Now 4 electrons go on for the bonds. 4 electrons go on for the bonding, 4 electrons. Then when you subtract, you get how many electrons? Total O3, 3 oxygen, 6 into 3, 18. 18 valence electrons. 18 valence electrons. Out of that, 4 bonding electrons. I like this 18 valence electrons in all three. O3. O3 has 18 valence electrons. Out of those 18 electrons, so 4 electrons bonding electrons, 4 bonding electrons. And the other, there are 2 bonds. How many then non-bonding electrons? You can get 14. That means what? 14 divided by 2, 7 pairs. So those 7 pairs I will distribute among these 3. Here 3, here also 3, and the other one on this. First I distribute the lone pairs or the non-bond pairs, the electron pairs. These 7 pairs first I will distribute on the terminal atom, then on the middle atom. Now you have to check whether it has reached octet or not. The 2 terminal atoms reach octet but not the middle one. Then what happened? I will convert this to a double bond. I'll convert this to a double bond. Then you get this structure. This is the first step. I'll use the white right here. Then you get double bond this side. There are 2 pairs, so one pair shifted, one pair is converted to this one. Then the other side you get a single bond. There are 3 pairs around this. Now why it shifted? To make central atom octet. Otherwise only 6 electrons around the central atom. Now 3 bonds and 1 lone pair. Now central atom has reached octet. Right? Central atom has reached octet. Then there's a possibility of forwarding this lone pair either side. From this side also is possible. Then I get the other structure. Then you get the two resonance. Then you get the two resonance structures. Okay, I'll try it like this. This O, oxygen, single bond. This side you can get the other one. Then you will put a lone pair on this. Here you get 2 pairs left. Here you get 3 pairs. So these two are called what? Resonance structures. These two are called what? Resonance structures. There's more than one possible structure. Resonance structures. And after drawing the resonance structures, you have to assign the formal charge. How to assign the formal charge? Look at this tree. This oxygen, there are 6. Oxygen has 6 electrons, but how many electrons allocated for this? 7. Oxygen allocated 7 here, because 1 for the bond and 6 for the 6 around the oxygen atom. That means 6 has become 7. That means 1 extra electron. That's why you have to put minus charge on this. So oxygen has 6, but how many allocated here? 7. Therefore 1 extra electron, therefore minus charge on this. This one, this middle central oxygen atom, how many electrons in the valence shell? Oxygen 6. So here 6 electrons are allocated, 3 for the 1 electron is missing, this oxygen. So this oxygen, how many electrons in the valence shell? 6. But how many allocated here? Only 5. That means 1 electron is missing. That means it's a minus. That means 1 electron is given out. That means we have to put a plus charge on this. 1 is missing. So the same scenario is this one also. Here minus, this oxygen is minus, and this oxygen plus charge plus. So therefore after that you have to assign the formal charge. So these are the 2 resonance structures. But all syllabus they put arrowhead for this, like a coordinate covalent. But now new syllabus we don't use. Some teachers they draw like this with an arrow like this. But that is not accepted on new syllabus. You have to put plus minus sign for this. Right? If you put an arrowhead, then no need to put minus sign here. New syllabus we don't use the arrowhead. This looks like coordinate covalent bond. Okay, so this is how you get it. Ozone, homo triatomic molecule. Any questions? These are I think you might have definitely done this in the theory class, right? Yeah. Then next one, resonance hybrid. Resonance hybrid. How to draw the resonance hybrid? Actually, the real one, in the real one, according to the resonance structures, what happened? There's one double bond and single bond. But in the real ozone, they have not observed this. Both the bonds are equal in length and equal in size and equal in energy. Therefore, resonance hybrid is the combination of both these oxygen, the double bond possible each side, and then you put a dotted line like this. Like this. And here you have to put 2 pairs. Here you have to put 2 pairs. And then this become minus half. This become minus half. And this become plus. Please raise the hand those who got this answer. Resonance hybrid. Right? Please raise the hand those who got both. I will highlight the final answer. This one and this one. Be careful about the lone pairs. There's a lone pair on this also. Yes. Okay. 2 of you have got it right. Very good. Very good. Now, so far in A-level papers, they haven't asked to draw the resonance hybrid. They haven't asked to draw the resonance hybrid. Resonance hybrid, therefore you don't need to pay much attention. Resonance hybrid, they haven't asked yet in A-level papers. A-level chemistry paper, not tested yet. Not tested yet in any of the papers. Therefore, in the future also they will not ask you to draw the resonance hybrid, but resonance structures, yes. Resonance structures, yes, but not the resonance hybrid. Right? Therefore, you don't need to pay much attention. But anyway, who is the chief? Of the paper setting panel, Professor S.P. Dharaniyagal. So there are, I think I told about this. If you want, I will share that with you. There's a part. Okay, wait. He's Professor S.P. Dharaniyagal. This one. I hope you can see the screen. He is the in charge of your A-level paper, but it's not available in bookshops. So you can see this is the correct structure of ozone. So he has given how to do it, like, as a small description about this. I mean, about resonance. And there are a few other molecules also he has given. This is about, I think it's NO3 minus. If you want, you can take a screenshot. It's NO3 minus. N2O, the resonance, and resonance hybrid. But resonance hybrid not necessary. They don't ask you to draw it, but you should know how to get the resonance hybrid. But they will not ask that it's not tested in the paper. And this again, N2O, right? N2O and NO, SO42 minus SO3 like that. Sorry. Is about this polarity and all, polarity, dipole moment and all. This again some other example, this carbonate ion, you can see the resonance hybrid of carbonate. But anyway, resonance hybrid not, and you should be able to comment on this resonance hybrid also, this stability. So now usually like they don't publish one, so Professor S.P. Dharanigal, I don't think you can find from the bookshops or any papers or anything, because now usually they don't appear in yes, he is the chief now A-level paper. But anyway, there are a few like articles like this, but it is available in the university. This is for the university first year students actually, right? Not for the A-level students. I got this from there. Right. Anyway. Let's see now back to the previous one. Right. Then draw the Lewis dot and cross structure for the HCN and POCl3. Okay, shall I erase this one? Have done? If anyone of you have not still writing down this, please. Okay, now I'll move to the next part. Draw the Lewis dot and cross structure of the HCN and POCl3. So HCN, if you can draw the skeleton, then it's easy to draw the dot and cross diagram. So hydrogen can form maximum one bond in any molecule. Hydrogen, remember, usually hydrogen will never become the central atom. Right? In heteroatomic molecule, hydrogen will never become the central atom because hydrogen cannot form more than one bond. And near the carbon and nitrogen, carbon is linked with 3 bonds. That is the most stable arrangement for the nitrogen. And carbon usually form 4 bonds, hydrogen 1 bond. So then if you have that general understanding, you can make the skeleton like this. Then you can convert this into what? Dot and cross diagram. You can convert this into dot and cross diagram. Carbon, you can get dot, cross, 3 bonds. Right. Then nitrogen here. Or they said hydrogen, you can put dot and cross. Then you have to check any lone pairs. In lone pairs, carbon and hydrogen no lone pairs. Carbon and hydrogen no lone pairs. So nitrogen, there's a lone pair left. So I put a pair of dots here. So these are dot and cross diagram of HCl. Dot cross. Right. Then next one, POCl3. How to draw POCl3? Phosphorus, central atom. Oxygen usually linked to the central atom with a double bond. If there's a single bond, there will be minus charge. If oxygen is linked with a single bond, definitely there's a minus charge. Oxygen usually double bond, that is the most stable. Phosphorus can have maximum 5 bonds. Then the other 3 will be chlorine. Then you can, if you get this skeleton like this, then it's easy to draw the dot and cross diagram. Phosphorus, then you get dot cross with oxygen, and each chlorine you have to put a dot and a cross, chlorine, dot cross chlorine, and here dot cross chlorine. That's how you get the answer. But what is the mistake in the last one? So this is not the final answer. Why? What is missing here? Who can tell me what is missing here? I have put the 5 bonds, 5 bonding pairs around phosphorus, but that is not the final answer. Yes, that is not the final answer. What is missing? Lone pairs, correct, yeah. You have to put the lone pairs around. Chlorine, there are 3 lone pairs. You don't need to use different colors, you can use the same color. But to distinguish, they'll put separately 3 lone pairs. Here also what? 3 lone pairs. Sorry, no, 2 lone pairs, sorry. 2 lone pairs. 2 lone pairs like this. Right. That's how you get it. What is the geometry? I don't know how many of you have done the geometry. So if you want to write HCN is linear. Linear. And this is tetrahedral. Tetrahedral. This is tetrahedral. HCN is linear and this one is tetrahedral. Molecular geometry also tetrahedral. Electron pair geometry also tetrahedral. This one also both are. Yeah. Right. Then question number 2. Okay, question number 2. Shall I erase this? Please raise the hand those who got the question number 3. Yes, Dulshan, you have to include the lone pairs. Otherwise, no marks in the exam. Actually, but there are some rules. When you draw the Lewis structure, I'll give some short notes on the Lewis structure because this is very important part in the LL paper. So the structure is a compulsory question. Without lone pairs, if you draw the Lewis structure, 0 marks in the paper. If you draw the dot and cross diagram without lone pairs, 0 marks. If you draw the Lewis dot diagram without lone pairs, then also 0 marks. That means all the valence electrons should be included in the Lewis structure. And Lewis structure, there should not be any unpaired electrons in the Lewis structure. If you draw Lewis structure with an unpaired electron, that is not the Lewis structure. That is not, that is, you are violating the Lewis theory. Actually, this was introduced by G.N. Lewis, a scientist. That's why I use the same name. This name of that scientist called Lewis. That's why we call it Lewis theory. And remember, this Lewis concept is valid only for the covalent bonds, right? Lewis structures, not the dot and cross I am talking about. Lewis, if they use the word Lewis, then you can't leave. Central atom usually should reach the octet. Central atom should reach the octet, and there can't be any non-bonding, unpaired electrons, and all the electrons in the Lewis structure should be in the form of pairs. You can copy down these points, then you will it will be useful in the exam when you are drawing. Then you can check whether you have done any mistake. Shall I erase this? Anyone still copy down this? Right. So please copy down the short note about Lewis theory or the Lewis structures. So right here, Lewis theory. If you check the Professor Dharanegala short, that article also, you will get it. Anyway, I'll give the summary of that. Lewis theory. Number 1, one rule, one condition is what? In the Lewis structure, the Lewis structure is valid only for what? Lewis structures only for the covalent molecules. That is number 1. Ionic NaCl, if someone is asking you to draw the Lewis structure, that is completely wrong. Ionic compounds, we don't use the Lewis structure. Lewis structure is valid only for covalent compounds. Only for covalent. Only for the covalent molecules. Second condition, Lewis structure should not contain should all the electrons in the form of pairs. All the electrons, all the valence electrons should be indicated, should be there. All the valence electrons should be there. Second one, valence electrons should be either as what? Either as bonding pairs or lone pairs. Either at bonding pairs and lone pairs. That means electrons, it should be in the form of pairs. There can't be any unpaired electrons. I'll put that red. Unpaired electrons should not be present in the Lewis structure. No unpaired electrons. no unpaired electrons, or no single. Unpaired means single electrons. Singly occupied electrons should not be present in the Lewis structure. And the other one, central atoms should reach octet. But sometimes expanded octet also possible. Mostly the central atom should reach the octet. That means not only central atom, you have to make all the atoms reach octet. Central atom and terminal atoms as well. Central atom, and that is the most stable Lewis structure. Central atom and terminal atoms. Central atoms and terminal atoms should reach octet. Then, so Lewis structure only for the covalent molecules, and all the electrons in the form of pairs, and either as lone pairs and bonding pairs. There can't be. And the most stable Lewis structure, and I'll put number 2 here. Out of the Lewis structures, there can be more than one Lewis structure. If there's more than one Lewis structure for a given molecule, we call them resonance structures. More than one possible structure, more than one possible Lewis structures are called resonance structures. More than one possible structures, more than one possible structures are called Lewis structures. Are called Lewis structures. Are called Lewis structures. And the other most important thing, number 2, the most stable Lewis structure. The most stable Lewis structure, minimum formal charges. Minimum formal charges. If formal charges are required, minimum formal charges or no more formal charges. I'll put no formal charges if on minimum. No formal charges on minimum formal charges. If required, minimum formal charges. And negative charge should appear on most electronegative atom. Negative formal charge, I put FC. Negative formal charges, formal charge on most electronegative atom. Most electronegative atom. That also very important. And opposite formal charges should be on the adjoining atoms. What? Opposite formal charges. Opposite formal, if you get plus and minus on adjoining atoms. Adjoining atoms. Those are the things that you have to consider when you I think you might have got definitely a theory note also. These things you have to pay more attention. Yeah, correct. Yeah, Dulshan is asking, yes, when you draw, that's why. Okay, very good question. Dulshan asks, sir, when we draw NO, there's one single electron around nitrogen, but we draw the Lewis structures. That is the problem. Therefore, Lewis theory has failed to draw the structure for NO. Yes, teachers are drawing, but that is not correct. So, Lewis theory is not a perfect theory. Lewis theory, there are some drawback. One drawback of the Lewis theory has failed to draw the structures for the molecules with odd number of electrons. Molecules with odd number of electrons, Lewis theory has failed. Because Lewis theory has told to all the electrons should be in the form of pairs, and then you can't put the pairs in NO, nitric oxide. Why? Nitrogen valence shell 5 electron, oxygen 6 electron. Good that you asked. Okay, I'll erase the screen here. Shall I erase the screen? Anyone still copy now? This place, raise the hand. Done, right? So you might have this in your theory note, but you have to pay attention to these parts, right? Then if you take, okay, since he asked NO, how many nitrogen, how many electrons? 5 electrons. Oxygen valence shell 6 electrons. Then you get the total 11 electrons total 11 electrons NO. So then you get you cannot have pairs, and then if you divide you get 5.5. It's not possible. So this is a molecule with odd number of electrons. What? Molecule with odd number of electrons. Therefore, for the molecules with odd number of electrons, Lewis theory has failed. Molecules with odd number of electrons, Lewis theory has failed. There is one drawback of the Lewis theory. You cannot draw the Lewis structures for the molecules with odd number of electrons. So therefore, NO is one of the best example. There are a lot of other examples. The total 11. Therefore, you can draw, but according to the Lewis theory, it is not accepted. That's why science is the kind of a subject where always is changing. So what you learn today get invalidated by tomorrow. So that is mostly applicable for the science more than the other subject. History, it won't change what has happened in the past. That's there as it is. But what is happening in the future, like science is like it's changing. Now actually what you learn today, now there are so many research going on at this even today. Every day the science getting updated. That's why after, at least in Sri Lanka, after every 8 years, there will be a syllabus revision. Now your syllabus started in 2011. Now they changed this in 2019. Next syllabus revision 2026. So 2019 and 2026 they are going to change this. 2027 the new paper. So this one like this after every 8 years, at least after every year 8 years they change. But other countries they change this annually. Still they update it. Therefore some theories because example Darwin's theory, right? Theory of evolution. So it's there are some scientists they don't believe on that. Some scientists they might do. So there are theory means not the perfect thing. Theory can be changed at any time. Right? Theory can change at any time. Therefore even your periodic table, so it's getting updated, no? So about 10-20 years the periodic table now it has changed. Therefore if there's something better than previous one, then they'll accept that and reject the previous one. That's what's happening. That is called the development. If there's no improvement, if there's no change at all, then there won't be any development in that subject. Therefore you can't blame for that. You have to accept that. So that if there's an improvement in that subject or in the that is applicable to the other subject also, if that is changing fast, that change is for a good change, then that's good. So there's a development. Otherwise that subject remain as it is. There's no development in the world also due to that subject. Therefore there are some parts, yeah, that's why there are a lot of research going on those things. If there are better evidences, if there is a better implement model than the existing one, then scientists they'll accept that and discard the previous one. So that means most of the things that we have learned so far, it has become false now. Dalton's atomic theory. So most of the facts now false, but still you learn it. Why? Because you came to this state because of those lies. When a person is lying, then what happened? The other people are checking whether he is actually telling the truth or not. There are experimental evidences. So then it motivates the others to do research, even though it's a lie. That's why that name also is there. It's still in the syllabus, right? Okay, next one. Okay, now number 2. Question number 2. Hybridization of the central atom of the following molecules. Please raise hand those who have done the hybridization. Those who have learned the hybridization. Muhum karne. Others not done. Tulishan Shamaya and Chamika? Shamaya? Hybridization. Okay, most of you are done, right? So, Shamaya again? No, okay, right. Only one of you have done it. Okay, don't worry. I'll explain. So, their hybridization means, I'll tell a short method for that also. Hybridization just to check the total number of bonding pairs and lone pairs. So, I'll give an example. total number of bonding pairs and lone pairs matters for the hybridization. Then you can easily find it. Let's see. I'll go short note for that. So let's see. I put bonding pairs and lone pairs. Total number of bonding pairs and lone pairs. Bonding means sigma bonds or sigma bonds. Sigma bonding pair, I'll put sigma bond. Total number of sigma bonding pairs, sigma bonds and 5 bonds you might have learned, right? Sigma bonding pairs and lone pairs plus lone pairs, right? So if you get sigma bonding pairs and lone pairs 2, then the hybridization will be sp. That means two orbitals are, if number of orbitals involve 2, then this one also, yeah. Then second one, if there are 3 total, then the hybridization will be sp2. Next one, if there are 4 total 4 pairs, then the hybridization will be sp3. If there are 5, you get sp3d. If there are 6, you get sp3d2. But A level you don't get sp only up to sp and sp2 and sp3 only. Right, sorry about that. Now you can see here the total pairs. Total pairs in water, 4 pairs around oxygen atom. Therefore, hybridization is always it's limited to the central atom. We are talking about this hybridization of the central atom. So how it become 4 pairs? 3 bonding pairs and 1 lone pair. I put LP, I put BP, bonding pair. 3 bonding pairs and 1 lone pair. So if you take this one, 4 pairs, how it become? 2 bonding pairs and 2 lone pairs, LP. That's how you get it. 2 bonding pairs and 2 lone pairs. Then third example. Shall I erase this? So what is the hybridization of oxygen? Sp3. That means 1 s orbital and 3 of p orbitals mix up. It's like this. If you have 1 apple and 3 pineapples, so if you want to distribute this to 4 friends A, B, C, D equally, same taste, same amount, then what is the best thing? You have 4 friends. To make it equal to everyone, you have to make a fruit salad, 1 apple and 3 pineapples. So then you mix up all 3 and divide into 4 equal cups. Then all 4 friends will get the same color, same appearance, same taste. So that's equally distributed amount. Then it's this also like that. All 4 bonds, all the bonds are identical here. NH, 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 all 3 bonds are identical. They have the same energy. So otherwise, what happen if the orbitals involved for this different, then it won't happen. Then it's unfair. Then third one, BeCl2. BeCl2. What is the hybridization? Can you quickly post the answer to the chat? Those who are done. Yes. BeCl2, beryllium. What is the total pairs? Beryllium group 2. So therefore only no lone pairs, only 2 bonding pairs. What is hybridization? Only 2 pairs, no lone pairs, only 2 pairs. Both are no lone pairs, 2 BP and 0 LP. Lone pair 0, bonding pair 0. Anyway, total pairs 2. Then what is the hybridization? SP. If there are 2 pairs around the central atom, the hybridization SP. Very good. Run 0, right, done. Then next one, BCl3. BCl3, how many pairs around the bonding, total pairs around the central atom? Boron group 3, outermost valence 3 electrons. So then only around boron atom, the total pairs will be 3. Only 3 pairs. Only 3 pairs. Only 3 pairs. So that means what? All 3 are bonding pairs. That means 3 BP and 0 lone pairs. 0 lone pairs, 0 LP. So then that is sp2. sp2. S plus 2 of P. That's how you get 3 here. 3 bonds. Always remember the number of orbitals involved in the hybridization is equal to the number of hybrid orbitals formed. If you only can copy down that. Again, what is that? Number of orbitals involved in the hybridization. Involved in the hybridization is equal to the number of hybrid orbitals formed. Number of orbitals involved in hybridization is equal to the number of hybrid orbitals formed. If you only can copy down that in a short notebook. Number of hybrid orbitals formed. Is that clear now? How many orbitals? Okay, this is very important. Number of orbitals involved in the hybridization. Yeah, if you take sp, how many orbitals involved in the hybridization? S and P, 2 orbitals involved for the hybridization. So the number, how many hybrid orbitals form? 2. Right? So you get 2 hybrid orbitals. If you mix s orbital and p orbital, if s and p orbital mix, you get how many hybrid orbitals? two hybrid orbitals. We call it sp like that. So they are oriented to minimize the repulsion like this. So this is orientation. S orbital and p orbital combined, then you get two of sp hybrid orbitals. They are oriented like this at angle 180 degrees. So if number of orbitals, that's what I explained earlier, number of orbitals involved in the hybridization equal, now imagine 1 of s orbital, 3 of p orbital, 3 p orbitals combined like this, 3 of p orbitals combined, px, py, pz, say px, py, pz. Then what is this? sp3, you get sp3. How many of sp3 are forming? 4 will be formed. So s orbital 1, this one 1, this one 3, then altogether you get what? 4. Then 4 hybrid orbitals are forming. 4 hybrid orbitals will be formed like this. So those 4 hybrid orbitals will be oriented in the space to minimize their repulsion in tetrahedral shape. If you attached 4 balloons, it will be positioned like this. Like this. So this is called a tetrahedral arrangement. Tetrahedral arrangement. Is that clear? So 4 hybrid orbitals are forming. What is the name of each hybrid orbital? Name of each hybrid orbital. Right. Right. So what is the name of each the hybrid orbital? sp3, no? Because name also 1 from S and 3 from P. Then you get what? sp3. The name also come like that, sp3. 1 from S, 3 from, so each hybrid orbital the name will be sp3. So that is common to the others also. These are the basic things, but anyway some students, I am trying my best to make it very simple, right? So like A level chemistry and use hybridization, resonance hybrid, like big words, but some students they like, don't get scared for the subject because of the words. So now technical terms, so sometimes you are not familiar, but actually nothing else. If you can teach this to a small one, okay, mix 1 apple and 3 bananas, how many cups you should make? According to this scenario, 1 apple and 3 bananas, how many cups you should make? 4 cups. So each cup you can say what? 1 apple and 3 banana. The name. That means number of cups, the fruit salad cups that you should make depends on the number of fruits that you are mixing. If you mix 2 fruits, you have to make 2 cups. If you mix 3 fruits, you have to make 3 cups. That's what you are. Now here we mix 2, altogether 3 fruits. It's like if you take fruits here like 1s and 3p. So we take 3 from p orbital. So it's like 3 bananas and 1 apple, say, assume. Then you have to make 4 cups, the fruit salad, like that. Okay. So this is applicable for the other, but anyway the sp2 and sp3 you are getting. sp3 they will not ask under the new syllabus paper, right? So therefore BeCl2, there are 2 bonds. So both are bonding pairs. Then the hybridization will be, to get 2 hybrid orbitals, you should get sp hybridization. There will be 2 hybrid orbitals like this. So then this also you should know how it is overlap. So this is sp and this also sp, and chlorine is what? P. Chlorine is p orbital. So the p orbital and sp hybrid orbital linear overlapping result this bond. How this BeCl bond is formed? Linear overlapping of sp hybrid orbital of beryllium with 2p chlorine, you get 3p, no? 3p unhybrid p orbital of chlorine. 3p unhybrid p orbital of chlorine with sp hybrid orbital of beryllium. So therefore you should know how to explain each covalent bond. In covalent molecule, the central atom hybridization you should know, and how each covalent bond is formed due to the linear overlapping or lateral overlapping, and orbitals involved in the formation of bonds also you should know whether they are hybrid or. That is also very important. A-level chemistry paper structured as a question number 1. After the resonance structures, Lewis structures, then the next part they can test mostly what? Bond angles, hybridization, orbitals involved in the hybridization, deducing the shapes of the molecules. Shapes of the molecules, hybridization, orbitals involved in the hybridization, sigma bonds, phi bonds, bond angle. So every year you get a question number, the compulsory question from both those things. First they ask the resonance structures and the Lewis structures. After that they can ask the rest like this. Okay, so it's very bit important. Please pay more attention for the hybridization part and the bonding and bond angles and the geometry of molecules. Molecular geometry as well as electron pair geometry. If you want, can copy down that part. Number one, okay, what is the highest priority in your general chemistry? Remember, now why are you doing this general chemistry revision? First, second and third units, you are getting A-level paper is structured as a question number one and few MCQs. To earn those marks, you are making this much of effort. Then you should know, no, don't put the same weight on all this. That's what I'm telling you now. No need to put the same weight for everything. Highest you had to put what? This Lewis structures, resonance structures, and Lewis structures and resonance structures. Lewis structures and resonance structures. So under that you get more stable, least stable, and all this. Then what is the next most important one? Hybridization. Then bond angles, and then sigma bonds and phi bonds. Then under hybridization, orbitals involved, like for the hybridization, that also bit important. You notice that the quantum numbers important, quantum numbers, and then hydrogen spectrum important, ionization energy important, and electronegativity important. Electronegativity bit important. So mostly this is very important. You are getting definitely a question from this. And the shapes of molecules, that's the other most important one. The shapes of molecules. The most important part, this part and this one. Mostly you get nearly 90% of marks allocated to the structure. This is a question number one from this one. So the quantum numbers, this one they can ask for the MCQs also. Ionization energy, electronegativity, that they can ask under MCQs also. But structure is a compulsory question mostly from these parts. Lewis structure, resonance structures, hybridization, bond angle, sigma bonds, phi bonds, and the shapes of the molecules or the geometry of molecules. And the stability of the molecules also. Resonance structures, they can ask the resonance stability. So please pay more attention, because you might have a lot of notes, like maybe books, like the teachers, they go long paragraph, keep on giving notes, but at the end you should know what you are getting, and you should know the percentage contribution for your paper from each section. So therefore, if there's more contribution to the paper from that section, you have to study that more. You have to do more questions. No need to do much questions from all the parts. So therefore, some parts you have to pay more attention. That's why some MCQs I explain in detail. Some structure is, like when I discuss in the paper class also, some questions I put more weight on some parts. Then there must be a reason. Some parts I don't explain much. There's a reason for that. That is the reason here, right? So therefore, now you have not answered the ALL paper, the full paper, right? You have not any experience of answering the entire paper. So like with time you will develop this. When the exam is getting close, you will do more past papers, you will handle it, and you will know the structure of the paper, and you know which sections more important. Now you don't know. You are copying down everything what the teachers are saying, right? And you are trying to memorize everything that they are giving, but no need. So there are some students, those who are not working much hard, but they go for the good results. Some students, like they study late night and maybe 6-7 hours per day, but still they don't go for the pass. So therefore, you should know what you are supposed to study first, right? So which part you have to pay more attention. That also you should learn. Otherwise, you are exhausted and you will do the first try, and your parents are telling you, my son studied a lot, and you always he is studying, but he couldn't get 3 years. But some parents tell, my son, he watched teledramas and everything, he managed everything, doing the school sports and maybe the cadet and maybe the school head prefect, and but they enter university also, right? And they are doing that game, this game, and all this. So there must be you should be able to at the end, what matters here, whether you are, because life is not only A level, so you should be able to balance that also a talent, right? Time management and managing your other things in that you are doing in the school and in your class. So that also important, right? Anyway, so CH4 it's very easy. BCl3 or CH4 how many? Okay, if you don't know the structure of the molecule, that is the end of hybridization. Then it's very difficult to get the answer. If you don't know the structure of the molecule, then that is the end of hybridization. So carbon CH4, there are 4 hydrogen. Hydrogen can form maximum 1 bond, and hydrogen always becomes the terminal atom. Are there any lone pairs around carbon? No. So all 4 are bonding pairs. So what is considered for the hybridization? Sigma bonds plus lone pairs. That's it. Sigma bond plus lone pairs. If sigma bond plus lone pairs 2, sp. If sigma bond plus lone pairs total 3, the sp2. If there are total pair, now here sigma bonds how many? 4. Lone pairs 0. What is the total now? Total pairs 4. Therefore, what is the hybridization? sp3. 1 from S, 3 from P. Then you get total 4. Is that clear? Right. So therefore, what is the hybridization of CH for carbon? sp3. sp3 hybridization. Any questions? Right. Then I'll erase this screen. Let's move on to the next part. Write separately the type of bonding present if. The type of bonding if present. It's very tricky question. If present. There can be sometimes without that also. Then you have to leave that blank. If you're adding the bonding in all these, sometimes if it is bonding is not there, then you will not get marks. Right? Separate the type of bonding if present in each of the following substance. So, okay, who can post the answer to the chat for this one? Now, type of bonding means you have to consider both primary interactions as well as secondary interactions. That means intra and inter both. Bonding means they don't specify whether it's covalent or okay, what are the type of bonding? Okay, I'll give a summary of that also. If when it comes to bonding, there are primary interactions as well as secondary interactions. Bonding, if you can quickly copy down this. Bonding, there are 2 types. Primary interactions and secondary interactions. Primary interactions and secondary interactions. So these primary interactions are also called what? Intramolecular bonds. Intra. Secondary interactions are also known as intermolecular bonds or intermolecular forces. Intermolecular forces. Then what are the main primary interactions? Covalent bonding. Covalent bonds primary. Covalent can be polar covalent, non-polar covalent. Then ionic bonding. Ionic bonding. Then number 3, metallic bonding. Metallic bonding. Metallic bonding. So secondary interactions, what are the types? Secondary interactions you can write most strongest one, iron dipole. Iron dipole. Number 2, hydrogen bonding. Hydrogen bonding. Number 3, dipole dipole. I put DP, yeah, dipole dipole. Dipole dipole. Number 4, okay, I have given this last week. Okay, then no problem. Yeah. So then you know this well, right? Yeah. So anyway, the dipole-dipole interactions I have given. And remember the strength also you should know. When you are given set of secondary interactions, you should know the strongest. You should be able to, example, iron dipole is more stronger than hydrogen bonding. Hydrogen bonding more stronger than dipole-dipole. Then if you take iron dipole, dipole-induced dipole. Dipole, I put IP, induced dipole, ID, induced dipole, like that. So you should know how to compare the strength also, right? Increase in order of the strength of intermolecular forces, you should know, right? Good. So I have given this before also. So then carbon dioxide, who can tell me number 1, the type of bonding present? Please post the answer to the chat, or else you can unmute and tell the answer. Yes. What is carbon dioxide, CO2G? What are the type of bonding present? Is that only covalent? Type of bonding means you have to consider both primary interactions as well as secondary interactions. That means intramolecular as well as intermolecular, both. Otherwise, you will not get full marks. So one is you get, now covalent also I prefer if you can write, because don't know in the marking scheme if they check whether it's polar covalent or non-polar covalent. That also I want you to write whether it's polar covalent or non-polar covalent. Yes. Carbon dioxide. Okay, let's see. Carbon dioxide is non-polar molecule. Carbon dioxide, what is this bond? That is polar covalent. Bond is this CO2, the polar covalent bond. And between CO2, what is the type of interaction? Between 2 non-polar molecules, because carbon dioxide is a non-polar molecule. This is also non-polar, this is also non-polar. Between non-polar molecules, what is the type of intermolecular force? Except I think one, all of you have done the bonding. It's not dipole-dipole. Carbon dioxide is a non-polar molecule, Dushan. Dipole-dipole exists in between polar molecules, dipole-dipole interaction between polar molecules. Carbon dioxide, yeah, is London. Good, Ransiluni, it's London forces. Yeah. So, or else we call it dispersion forces. So, I'll write the answer now. What is the type of molecule? The carbon dioxide, polar covalent, and London forces or dispersion forces. Number 2, water, solid. That means ice. What is the type of interaction? Whether it's ice or liquid water or water vapor, what is this bond called? Polar covalent. Between water molecules? Between water molecules, what is the type of interaction? Hydrogen bonding. Hydrogen bonding. Sometimes in biology, you call it similar between similar molecules, the cohesive and adhesive forces, something like that. Okay, so here you get type of bond in polar covalent and hydrogen bonding. Hydrogen bonding. Next one, sodium chloride NaCl. Solid NaCl. What is the type of interaction? NaCl. Yes, I am expecting the answer from this one from everyone. NaCl. What is the type of interaction? Then what are the bondings? Yes. Quickly pause the answer. Number 3, the sodium chloride. What is the type of bonding present? This is very important. Most of the papers, the students they haven't done it properly. Remember, sodium chloride has ionic bonding. Are there any other force other than ionic bonding? There, Adulshan, you are correct. Only ionic bonding. So sodium chloride, no secondary interactions. If you can put an arrow and write no secondary interactions in sodium chloride. No secondary interactions in NaCl. Only primary interactions. No ion dipole. That happens me. If you dissolve NaCl in water, look at the physical state. What you are saying is correct. If you take NaCl aqueous, right? If you take NaCl aqueous, then you can write what? Ion dipole interactions. Be careful about the physical state. That's why they have given the physical state within bracket. Right, good. Then what is HCl gas? Gaseous. That means if it is HCl gas, we call it hydrogen chloride. We don't call it hydrochloric acid. Hydrochloric acid, you have to tell if it is HCl AQ. If it is HClG, we call it hydrogen chloride. Right? So that's very important. Yes, what is the type of interaction in HCl? Within the molecule, polar covalent. Polar covalent. Yes, quickly post the answer to the chat. HCl. What are the type of interactions? Polar covalent and dipole. I put dipole. Right. Or hydrogen bonding. Yeah, correct. You can write hydrogen bonding. Okay. This type of here. Then argon. Polar covalent, the primary interaction. Secondary interaction, you can write either hydrogen bonding or dipole. But even the first one, what also if you write here in the marking scheme, sometimes they accept both. If you write dipole interaction also, they will accept. But it's better to write hydrogen bonding here. Right? So H bonding, right? The next one. Last one. Argon. What is the type of interaction? Argon, liquid argon. Liquid argon, what is the type of bonding? Yes. Most of the time, this others, some of you are not replying at all to the chat. Chamika and Chamaya. Yes. Okay, good. Dulshan gave the answer and Ransuluni also gave the answer. Very good. London forces. Yeah, okay. Chamaya, good. London forces. Very good. So that is about now. It's not hard. Your main target to get full marks. Structured essay question number 1, and you are getting about 5 MCQs in the MCQ paper from this one. Not less than 5 MCQs. Sometimes about maybe like 3. Sometimes about 3 MCQs. Right? Because essay type you don't get from the general chemistry first 3 lessons. Right? Okay. Then I'll get the screen. What's the time now? It's 10 to, okay, what, we have about 10 minutes. So then next paper, revision number 2. Look at the screen. How many of you have done this? Please raise the hand. This I gave, you had about 2 weeks, right, to do this. And I'll post a new paper tomorrow. Then we'll have about 1 week to complete that all. Have done this? Please raise the hand those who have done this. Right, good. Okay, now first one. This also A-level pass-through question. M is first row 3 transition. Atoms of this element has 6 unpaired electron. This is a very important one. Underline or highlight here 6 unpaired electron. Identify M. Which 3D element has 6 unpaired electron? What is 3D? What are the 3D elements? 3D first row 3D. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, like that. Those ones, huh? Copper, zinc, like that. Lead and zinc. This is 3D. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. There are 10. There are 10 elements. So out of these, which one you have done the electronic configuration? They don't directly ask write the electronic configuration of this element and the atomic number. So this is very important. 6 unpaired electron. Which one has 6 unpaired electron? This one you get 3d5 4s1. This is the element in the 3D. Which one has 6 unpaired? 3d5 means there are 5 unpaired electrons. 1, 2, 3, 4, 5. So unpaired electrons, 5 unpaired electrons. And 4s1 1 unpaired electron. So chromium has 6 unpaired electron. What is the element M? Chromium. Or you can put the symbol Cr. Very good. Those who have got the answer. Chromium. Right. Samaya correct. Right. What about the others? Okay. Write down the complete electronic configuration. Now this is how you get the questions from the configuration also. Then you can write 1s2, 2s2, 2p6, 3s2, 3p6, 3d5 4s1, 3d5 4s1. Right? Please raise the hand those who have got this. Correct? Right. Then next one. Okay, chromium is the 3D 3d5 4s1. The next one, I'll erase the screen. Out of the first 8 elements, the element which form most stable diatomic molecule. Highlight the word most stable who will form the most stable diatomic molecule? Most stable diatomic molecule formed by whom? Yes? Most stable diatomic molecule. First 18 elements. That means what? From lithium to argon. Lithium to hydrogen helium, lithium neon, and then sodium to argon. These are the first 18. Sodium to argon 10, lithium to neon 10, then hydrogen and helium, then you get 18 altogether. 20 plus 18, no? Yeah. 8 plus 8, 16 plus 2, 18. Hydrogen to argon, except potassium and calcium, right? Potassium and calcium not included in the first 18 elements. This is also a possible question. What is the answer? Yes. Who formed the most stable diatomic molecule? Most stable. I didn't get the answer yet. Chamaya gave oxygen. Any other answers? What about the others? Diatomic molecule means N2O2, Cl2, F2, I2 like that. Diatomic. Diatomic and double bonds, triple bonds don't mix up. Oxygen diatomic as well as double bond. Oxygen diatomic as well as there's a double bond. Hydrogen also diatomic but single bond. Single bond. Nitrogen diatomic is there's a triple bond. It's very important. Nitrogen triatomic and there's a triple bond. There's a triple bond. Okay, what is the answer now? The most stable one is out of these which one? Which one has higher bond energy? Answer will be nitrogen. Answer will be nitrogen. Identify the element. Element means you have to write just the element, right? Symbol or the name of the element. no need to write the molecule. They are asking to attract, because this nitrogen is the element which form triple bond between its atom. It's a diatomic molecule having a triple bond. Triple bond is more stable than double bond. Double bond is more stable than single bond. That's why N2 gas in the atmosphere 78%, but is less reactive. Nitrogen 78%, even though it's saying 78% in the atmosphere, it is less reactive. Why it is less reactive? Because of the triple bond. Therefore, nitrogen is less reactive than oxygen. Oxygen 21% nearly, but is more reactive than nitrogen. That's why the nitrogen is used to fill electric bulbs even. So right. Then next one. Okay, Shamaya gave oxygen, Dushan also gave oxygen. No, answer is nitrogen. Okay. Then number 2, identify two elements that form bond with highest ionic character. Highest ionic character. Which pair of elements out of the first 18? Which form highest ionic character? Yes? Any volunteers? Which pair form highest ionic character out of this? Group 1 top, right? Group 1 bottom, and group 7 top, having the highest electronegative difference. Highest electronegative, that means fluorine. Fluorine group 7 top and group 1 bottom. Group 1 bottom. That will be the highest ionic character there. Yes? Na and fluorine. Sodium and fluorine. So this is how you have a topic called long form of the periodic table, and the periodic table you have a topic in your general chemistry, the resource book. So this is how you get the questions from the periodic table. What is the answer for this? Na and F. Sodium and fluorine, F. Next one. Identify the element that has the highest boiling point. Which element has the highest boiling point? Yes. Who can post the answer to the chat quickly? Who has the highest boiling point? Yes. Out of the first 18 elements. Sodium. They are asking the element, not the compound. Chamaya put KCl for the previous one. So did you understand why it is KCl? You can't take Chamaya because they are asking the first 18 elements. Potassium is 19. Did you get it? Potassium atomic number 19 is 19th element. They are asking the first 18. See the tricky question. And you who put this sodium fluoride? Okay, correct. Dulushan gave lithium chloride. Lithium you can't take because you have to get the highest electronegative difference below, down the group electronegative decrease. Group 7 top and group 1 bottom. Then the highest ionic character. Right? What is the answer for highest boiling point? Some of you gave sodium, some of you gave argon. Argon, highest boiling point. Argon is a gas. Gas is having low boiling point. Who has the highest boiling point? I still didn't get the answer. This is like oral chemistry questions. This is a A-level past paper question. This is A-level past paper question, right? But I still didn't get the answer. Out of the first 18 elements, which one has the highest boiling point? Answer will be, I still didn't get the answer. Not metals, but the number which form lattices. Carbon exists as graphite and diamond. Carbon, if you only can check the internet, even the boiling point and melting point graph of the first 18 elements, carbon is at the peak. Carbon has the highest group for carbon because of the formation of lattices, graphite and diamond. Carbon does not exist in pure form as one element, like the others. So it will form a lattice. Identify the gaseous element that can be used as a fuel. Number 4, what is the answer? Gaseous element that can be used as a fuel. Yes. Out of the first 18 elements, which one can be used as a gaseous fuel? Yes. Very good, Transiluni. Dulshan correct, Transiluni correct. What about the others? Very good. Chamaya also correct. What about Chamika and yes? Chamika is not very silent today. Chamika? Shamika has left. Okay, right. Maybe connection problem. Some of them have requested recording. Okay. If don't worry, even if you join the class, if you want to listen to this again, you can request the recording. No problem. I'll send it. If you want to watch it again, any section, small part even. Okay. So answer will be Hydrogen, very good. Hydrogen is the fuel. That is the most environmental friendly fuel. But don't write the formula, just write the symbol of the element H. Okay, then the rest I'll discuss next day. So then this paper pass, I'll post one more paper, then you have enough time to complete that also. So the rest I'll discuss next day. It's almost 10:30. Right, okay, then we'll stop for today and let's continue the rest next day. Good night and God bless you all.